So we got started. Everybody be very welcome to the webinar with Pinnacle, with Andrea from Pinnacle, a scientist, a fermentation scientist, who will be talking about low alcohol Pinnacle yeast. And we also have Mendel today. Mendel is a prof sales team and is part of Brouwland sales team. And he'll be presenting, asking questions, making sure that everything goes smooth. I work for Brouwland as well for the marketing. So again, be very welcome, Mendel and Andrea.
Hi, welcome everybody. Like Sam said, I also work at Brouwland as sales advisor. And yeah, today we're going to talk about low alcohol beers, of course. And I give the flame to Andrea to start the webinar.
Sure. Thank you, Mendel, and good evening, everybody. We are a huge crowd, so 315 people. So I'm excited, and thank you very much for taking the time to listen to my presentation. I'm going to share my screen now, so you can see a bit the presentation. Mendel, let me know when you see it.
Yes, it's okay.
Okay. So before starting, I want to give you a bit, let's say, a small agenda of the topic we'll speak about. First, I will introduce a bit myself and my company, AB Biotek, that I'm working for. Then I will introduce a bit the concept of low alcohol beer, starting from the market and going a bit more in depth on the, let's say, on the possible approach that a brewery, both big or small, can take to produce low alcohol beer. And then we'll make a focus on maltose-negative strain. So strain that actually can produce low alcohol beer. And please hold on until the end, because then there will be a bit of a session of success stories. So customer that actually produced our strain, and I can give you some details of what they did. And in the very end, also, I will share with you some recipes, ideas to kind of trying to inspire you, or at least, you know, hear your opinion on different possibility to create a great low alcohol beer. So I'll start with my presentation, but seems like, okay, here we go. So here is me in a brew house. Actually, I'm Andrea Felician. As you can guess from my accent, I'm Italian. I'm a Master of Science in Food Science and Technology, and I make 2 theses in brewing technology. I worked briefly as a brewmaster in an Italian craft brewery. And then I went on the, let's say, other side of the fence, working in fermentation in the US and UK for creation of sourdough, so in bread. And since 2023, I had this amazing opportunity to join AB Biotek and actually lead the application team and making a bit of technical sales on beverages, and particularly focused on beer. So actually, I am the guy that developed and make the application for this yeast. So I hope I can give you some good insight on this. After my introduction, I want to give you a bit of an introduction of the company that I'm working with. The company is called AB Biotek. Our brand is actually Pinnacle, which is our brand of yeast for beer. And we are a global company which has different R&D centers around the globe. Particularly the one in which I'm working, you can see it on the top right end of the slide. And this EMEA center in Eteleur, when actually we test all our yeast strain for beverages and we make application. So being as close as possible to reality. Here you can have an idea a bit on our what, let's say, is in our lab and how the team look like. We have different capabilities. Of course, fermentation. We can run around 320 fermentation a week in small flasks. But we also have the opportunity to check the microbiology of our yeast, make analytics, so chemical analysis, so the part of aromas, sugar, acids of the beer. And also we have a trained sensory panel on sites. So we can actually characterize fully our product. So enough, I think, for introduction, and let's dive into the topic and the market. So why low alcohol beer is actually interesting for the brewers. It's interesting because if you have a brewery, you know, the market is kind of flat for brewing at the moment. So it's not growing a lot, but actually the only category growing is low alcohol and non-alcoholic beer. So what we call NABLAB. And growing this category also, you have to rethink your way of brewing. It's not like brewing normal beer. It's a bit different. And particularly in the craft sector, this journey has only just started, and it comes with some difficulties. For the craft, mainly some blockers related to the capex investments and the type of machinery you need to actually produce low alcohol beer, apart from the technique. But also for the big breweries, I'm talking about, you know, the Heineken and AB InBev, it comes with some challenges regarding sustainability. And I think that our solution can actually, maltose-negative yeast can actually help both. One side to reduce costs, I mean the big guys, and also enable craft brewer to craft good quality low alcohol beer. So let's have a brief look a bit in, how a non-alcoholic beer is produced. There are actually, let's say, three main different steps for low alcoholic beer production. One is in the brew house. In the brew house, we can opt to make the standard mash, so, a typical 12 or 15 plate of beer that then we will de-alcoholize. Or we can make a step mash, so change some of the parameter in the mashing to adapt the mashing scheme to obtain low fermentable sugar wort. And we will go in depth in this technique in a moment. Then there are also different in fermentation. We can make a normal beer with the right ABV, as we do, or you can opt for two different techniques. One is called cold contact, is a typical German technique in which you put the yeast in contact for 1 to 3 days at very cool temperature, so 1 to 4 degrees. So basically the yeast doesn't ferment, but even if it doesn't ferment, the yeast cells has ability to actually intake some of the unpleasant aroma of the wort. And so in the end, you can have a reduction of some of the worty aldehydes. Again, we'll speak about the worty aldehydes and the aromas later on in the presentation. And the last option is actually maltose-negative yeast. Maltose-negative yeast is a yeast that actually metabolizes only simple sugar, so glucose, fructose, and sucrose. So it doesn't metabolize any maltose and any maltotriose in your mash. And this can be another good option to actually reduce the alcohol content. After this, you have two different techniques that you can use. So a post-treatment can be distillation or membranes. So you can vacuum distill like under pressure, distill the beer, and with the alcohol system obtain a 0-0 beer, or you can use membranes to take out the alcohol. But that actually is pretty expensive in terms of capex because you have to invest a few million in this equipment. Or otherwise, if you make a beer with maltose-negative yeast, you don't need all of this. You just need, and it's fundamental to have, a pasteurization unit. So you need a pasteurizer to block the fermentation and kill the yeast off and stabilize the product. That will lead you to a beer of good quality of below 0.5% alcohol. So one thing we ask ourselves when we started to develop this yeast strain is, okay, what success look like, in our opinion, for having a non-alcoholic or low alcohol beer? And we actually give a bit of, I think, 4 main topics on, we give an answer to ourselves in 4 main topics that you see here. So we wanted a beer that actually produce low alcohol level, or at least can be compliant to the table you see on the right, which is a table of some of the main country that has laws on low alcohol or non-alcohol beer. Second, we wanted a yeast strain that can reduce worty aldehydes notes. So, the typical aroma of wort of like cooked potatoes, hay, grass, cereal. Third, yeast strain that can drop pH well. This is particularly important to actually go into a safer zone to avoid spoilage, because a brewer doesn't think about it, but again, you have to rethink your way of brewing. If you're brewing low alcohol beer and you have alcohol at 0.5% or less, there is also the possibility to have pathogen in your beer growing. So we have to take care of that, yeah? And then the fourth point is a clean aroma, so without off notes like sulfurs, diacetyl, or 4VG. And this is how we came out with our yeast, which is Pinnacle low alcohol. Pinnacle low alcohol is a very interesting strain. It's a Saccharomyces cerevisiae that is very versatile and can actually produce a very clean aroma. Generally, if you start at a 5 plate of wort, it will give you around 0.5% ABV with an attenuation between 10 to 18%. And also, some of the key characteristic is that it's non-phenolic, so doesn't give you the spicy note, typically of the 4-vinyl guaiacol. It's low in diacetyl, pretty neutral, reduce well the worty aldehydes, and has a good acidification power. And can be combined very well also with dry hopping. All of this in the convenience of a dry yeast package that you will ferment generally as a normal yeast, so around 50 to 100 grams per hecto, and with a fermentation temperature of 18 to 25 degrees.
Hi, Andrea. Sorry to interrupt you. Can you go a slide back, maybe?
Sure, absolutely.
Can you give a little bit more explanation about the high acidification power, maybe?
Yeah, this will be in 2 slides. So I will give you a full explanation on that in 2 slides, but basically I'm referring of the drop of pH.
Okay,
so possibly you have a drop in pH when you ferment with any yeast, you have a drop in pH, and we actually studied this for our Pinnacle low alcohol. So I will give you all the information in the slide after this one.
Okay, thanks.
No problem. So, of course, you can see here a bit the competitor landscape. Of course, we were not the only one thinking about it, but also other supplier of both dried and liquid yeast have a thought of having products out that can make low alcohol beer, and they are all different. Of course, it's a choice of the brewer to find the one that fits better his purpose. Starting from the left, we have Fermentis LA01, which is a Saccharomyces cerevisiae, but is a Chevalieri, so is a yeast that actually is phenolic. So very good yeast if you want to produce a Hefeweizen or a Belgian ale that has a spicy note, but not very good if you want to make a lager, for example. Then we have the Christian Hansen Nier, which is another, it's a non-sac, so it's a Pichia. This yeast actually is pretty interesting, but it's only available in deep frozen starter, and actually it's claimed to produce a beer up to 0.0%, but there are some concern if you want to go to 0.0 on the sensory point of view. Then there is the Saccharomyces ludwigi from White Labs, actually a strain isolated by Toom, which is a broader scope. It's liquid, but actually is pretty estery, so will give you a lot of fruity flavor. So not exactly what you want if you want to brew a lager. And then there is basically the Lallemand-Lona and Pinnacle low alcohol, which are similar strain. Similar, I mean, they are different, but they are similar in terms of characteristic because they're more in broader scope. They are non-phenolic, so you can actually make successfully a good IPA or lager with it. Here to answer the first question, Mendel, is what I mean regarding the acidification power of the yeast. These are data that come from our lab when we conduce multiple trial. It's important that when you make low alcohol beer, you adjust the pH at around 4.85 before transferring to the fermenter. And our low alcohol yeast strain actually has the ability to acidify up to 3.9. We saw in our trial starting at 4.8. This is pretty important for 2 things. First of all, because 4.2 in pH is one of, let's say, the kill step for bacteria, for pathogen bacteria to grow. It's not exactly true that they cannot grow below, but they have more difficulties. So if you reach a pH below 4.2, it's safer for you and for your beer. And second, also, having a strain that can acidify a bit more, give a better balance in your taste, because you have to imagine that this strain will metabolize only a small amount of sugar, and the maltose will remain there. And maltose, you can perceive it sweet. So if you have a bit of a balance with acidity, that actually give a better refreshing taste. So we spoke a little bit about the pH. Now let's deep dive a bit into what I mean when I speak about sugars and fermentability. You can see here there are in this slide there are a couple of mesh and possibly some fermentation. Starting from the column on the left,
Andrea, can I interrupt you?
Sure.
About the previous slide. Maybe it's also interesting to tell the brewers how to adjust the pH when they brew the beer.
So you can adjust pH with generally lactic acid or phosphoric acid if you prefer at the end of the boil. You generally adjust it also before to have a better conversion of your enzymes, so in the mesh. But actually, it's important also to adjust it at the end for non-alcoholic beer, so you can have a better drop of your pH. Can I go on, Mendel? Yeah.
Yeah.
Okay. So here in this slide, as I was saying, it's mainly focused on the sugar. You can see on the left the breakdown of a, let's say, standard mash fermented with a ale yeast. You can see here that the monosaccharides, the green, actually, the green part is 12%. So usually it's 12 to 15% in a normal mash. And you can see actually the difference if you ferment it with a maltose-negative yeast or a maltose-positive yeast, so your normal house strain. You will yield 2.4% ethanol in one case, while you will yield only 0.4 in the other one. On the right, the last column, instead, you see a high temperature mash fermented with a ale strain. So going at higher temperature, you can reduce a bit the monosaccharides and actually have a bigger fraction that is unfermentables. This is not what you want generally in a normal beer, but it's definitely what you want in a low alcohol beer, in which you start, as you can see, for a very weak wort, so around 5.5 Plato. There are actually here, I want to explain you a bit some techniques on how can you actually tweak the recipe based on the raw material you use and the process in the warm side of the brew, so in the brew house, to actually reduce the quantity of glucose. And why you want to reduce this quantity of glucose? You want it to reduce it because the yeast has just to make enough fermentation, in this case, to create low alcohol as possible and clean out the off flavor that come from the wort. So this is why it's important to minimize actually the concentration of glucose. You can see on the graph on the right that there is the difference of using unmalted barley or unmalted wheat. You can see that you reduce from 10% up to 5 or 7% the simple sugar, the glucose. So this is pretty important. And another effect that you can see is in your process when you're mashing, you can opt for a standard wort, or you can also opt for single step mash at 74 or even 85 degree. And you can see that also here you have more dextrin and you reduce a lot the monosaccharides part. So again, less fermentation for a low alcohol strain. And also the last two columns on the graph at the bottom, you see the effect of the water-grist ratio. So if you have a water-grist ratio, my suggestion is mash thick. So the thinner it is, the more monosaccharides you're going to produce. The thicker it is, the more dextrin you're going to produce. And this is actually what you want in a low alcohol beer. So we spoke a lot about them, so I think it's good to give a bit of introduction of what we mean in let's say in brewing science with worty aldehydes. These worty aldehydes are generally compounds that you find in the wort. Are around 40 compounds that are generally have an effect on the flavor and the taste of your beer and the smell of your beer. The main one are the 6 that are mentioned here, like 3-MB and 2-MB, or for example, methional. And one, if you remember from the previous slide, one of the key topics for us for having a yeast for low alcohol beer was the ability to actually reduce these worty aldehydes below the sensory threshold. So we made a full study with a big university in Germany on this, in which we actually analyze how much of the worty aldehydes are present in the wort and how much we can reduce with a cold contact technique or using a maltose-negative strain. Here you can see a graph that is expressed in percentage of flavor threshold. So you probably all see this black line. This graph means everything that is above the black line, you will be able to perceive from a sensory point of view, so in taste and aroma. Everything that is below, you will not be able to perceive. You can see for all the 6 main markers, basically they are, of course, as you can expect, very present in the wort. You can reduce quite a bit of them with cold contact, but not all. So 2 of them, the 2-methyl-propanol and the methional, you're still gonna perceive them in the finished beer. But if you use
Andrea,
a maltose-negative...
Can I interrupt you?
Yeah.
Maybe it's good to give a little bit more explanation about the cold contact, since we're also talking about it. Maybe it's good to explain it a little bit more.
Yeah. Cold contact is a technique I was mentioning in the beginning, in which you actually add the yeast directly to the beer, but you keep it cold. So you keep it for 2 to 3 days, 4 days at 1 to 4 degrees. And then you keep it there, and the yeast itself has the ability to actually clean up some of the flavor of the wort just staying there. But as you can see from this, if you use a yeast that ferments, like you can see in the green column, actually there is a higher reduction of these worty aldehydes. So it appears to be the better option even compared to cold contact if you want to reduce the worty aldehydes. Apart from this trial, we also run other trial. This is a graph that we take from some trial run in a pilot plant, so a 500-liter brew in Belgium, with a university in Belgium. And you can see actually that there is a very big reduction of these worty aldehydes with the different days of fermentation, but also with maturation. So it appears to be beneficial actually for the beer, for the low alcohol beer, to actually mature a bit to clean up even further the worty flavors. Okay, at the beginning, if you remember, I also spoke a bit about efficiency for big breweries and not only for small. And I would like to give a bit of an insight in that. Here you see a process of making beer industrially and then with dealcoholization, so 0-0 beer. And you are for sure all familiar with that, so I don't have to explain anything on this. But for sure, what is interesting is to see what are the main costs for the breweries, which are generally the electricity and the natural gas. And why using a maltose-negative yeast strain can be a sustainable solution, good for the environment, but also, let's say, important in cost saving for a big brewery that brew in high gravity. This can be because you can actually take 2 approaches. The first one is save on your malt. Generally, you want to have some extract, and in industrial brewery, you brew at 15 Plato, so high gravity, and then you take the alcohol out. But of course, if you brew with a maltose-negative strain that just ferment 10-20% of your sugar, you will have way less alcohol to take out, and also you can start with a lower Plato, so you will save on your malt bill. So apart from the money of the malt, you will also save in tons of CO2 for hectoliter of beer produced. Or you can take another approach, and the other approach is still to brew in high gravity, but fermenting with a maltose-negative yeast strain that will give you way more extract. So that will give you more production throughput from your brew house, because you can boil less volume, so you'll have a reduction in cost of gas for boiling. And also then you can dilute your beer more because you will have higher extract. So this will actually give you a cost saving. And on top of that, with both techniques, if you have less alcohol produced, then it's easier to take it out both with membranes or the alcoholization system. So will be very good for energy efficiency, also for big brew houses. Apart from this, we also studied a bit the effect of the hops and the hopping in low alcohol beer. So, I mean, we know that one of the most popular style, probably with lager, is IPAs. So we wanted to have a deep study and understanding on how the hops and the low alcohol beer actually interact. The first thing we can say is that we suggest actually to dry up cold. So during maturation, if you want to have a stable product and avoid hop creep, so the hop creep effect, while if you will dry up
Hi, Andrea.
more,
Maybe
Yep.
maybe it's good to give an explanation about hop creep,
Sure.
because I think some brewers may not know this.
Absolutely. So I think this slide is perfect for this. You came at the right moment. Generally, what we mean by hop creep is when you dry up a beer, in the hops, there are present some natural enzymes. These natural enzymes will actually, there are some amylolytic enzymes that attack some of the sugars of the chain sugar, like the starch, the dextrins mainly, you will have in your beer remaining. Attacking this dextrin, they can release simple sugar like glucose, and then they start fermenting again. So you will end up with a beer, in a normal beer, particularly for IPA, with a beer that has a higher ABV than expected and actually can have also a sluggish in fermentation to finish and maybe also diacetyl spike. So it's important to know that this can happen in any brewery if you dry up your beer generally. So, but there are ways to minimize, let's say, at least in low alcohol beer, this hop creep effect. And for sure, one of the way is to dry up cold, because in this case, then you will go to pasteurization, which is mandatory for this type of beer, and you will denaturate this enzyme. So you will never see hop creep. Another way, though, that we studied, and you can see here one of the graphs from our pilot plants trial. Both you can see here there are three different yeast. One is ours, but also the other are the competitors' yeast that we tried. So it worked for every yeast. So it's a common problem if you brew low alcohol beer. If you dry up warm, for example, in this case, we dry up at 20 degree after 1 day of fermentation, you can see actually an increase in the alcohol, and that is due to this enzyme and the hop creep that I just explained before. This increase can be up to 0.2% in a 5.5 Plato. So it's important to know that because maybe you want to use a biotransformation power of the yeast to get a different type of aromas from your beer, but it's important to know that you have to balance your recipe very well. So in this case, be aware that you can expect a 0.2% increase of alcohol. In the beginning, if you remember, we spoke also about one of the last point that was cleaning flavor. For us, it's paramount that the yeast doesn't have off flavor or produce a lot of off flavor. And luckily, Pinnacle low alcohol, it's not prone to produce a lot of acetaldehydes or H2S. And to be honest, neither a lot of esters or superior alcohol, because generally all of these are linked, that are the aroma of the yeast, are linked with the yeast growth. And since the yeast grow very little because it just ferment 18% of the sugar in your mash, there is actually less production of aromas. But with that come also a good thing, which is less production of diacetyl. And as you can see from this graph, basically diacetyl it's below the 50 ppb and below the 20 in 1 day of fermentation or 2 days of fermentation if you dry up the beer warm. So
Sorry
this
to
is
interrupt you, Andrea,
Yep.
but can you give a little bit more explanation about what diacetyl is, maybe?
Yeah, sure. Diacetyl is a typical compound that is an intermediate of the amino acid metabolism of the yeast. And generally, to speak in simple term, it smells like butter, and it's typically a defect, both in ales and lager of the beer. And this kind of defect, generally the yeast has the ability to produce diacetyl first, and then in fermentation it reabsorbs the diacetyl. It's always linked with yeast growth. So if the yeast grows more, there is more production of diacetyl. And the threshold limit is actually 50 ppb, or in some cases for very light lager can be even up to 20 ppb. We're talking about part per billion, so very, very it's a molecule that is very, very smelly. Yeah. So in this case, with our Pinnacle low alcohol, we saw that actually already in 2 days of fermentation, you can reduce the acetal below the sensory threshold, which is pretty amazing. Yeah. The last technical point I have, and that we studied of our yeast, regards what we call the flocculation or the sedimentation, basically, of the yeast. Generally, maltose-negative strain or low alcohol strain are not too good at flocculating. So by flocculation, I mean going down to the bottom of your fermenter and, stays there, so you can take it out and then have a clean beer. And here I want to show some data because we found that our yeast is pretty good at flocculation. On the top right, we see some pilot plant trials of maturation days of both competitor yeast with dry hopping and our yeast with dry hopping and without. And you can see that in both cases, Pinnacle is one of the lowest NTU. NTU is turbidity units. You can see actually that is a gray line and a yellow line that actually are some of the lowest values. And we also make another kind of test. So let's say indirect test, measuring the NTU is direct testing, but we also wanted to measure the cells in suspension. So what you see, the graph you see at the bottom, actually show 4 different brews that we analyze the quantity of cell in suspension, in fermentation, at the end of fermentation actually, and the number of cells after 4 days of maturation that we found. As you can see, there is a significant drop. Basically, you have a high quantity of cells that when you are fermenting, and then they drop down a lot, the quantity of cells you will find in your beer when you're maturing the beer. And this actually gives you an idea of the fact that the yeast is flocculating well, because all the yeast will be at the bottom, so you don't find it in your beer no more after it finished fermentation. So enough probably now with with more the technicalities, and I want to share with you some of our luckily of our success stories and some of the customer actually that provided us beer. A couple of weeks ago, there was a big event in Munich called DrinkTech, and we were very happy to share with the crowd a lot of beer for our customer. And you can see that the brewers has been really inspired by our product, and I'm very proud to say that they make an excellent job in interpreting a lot of different beer styles. You can see, for example, the brewery from Germany or Iceland that actually make a lager beer, so a refreshing low alcohol lager. But we had a brewer from the Netherlands called Frontal making a New England IPA, and also a brewer from Switzerland making more a West Coast IPA and also a wheat beer. So this is just to give you an idea of some references that actually this is like, a color on your canvas. If the canvas is your beer, this is just a color you can add to give a different shade and make, a nice new low alcohol beer that you can actually insert in your portfolio for your brewery. So speaking about recipes, I actually reported here a couple of recipes or suggestion recipes. Of course, you don't have to follow them if you don't want, but this is a bit of a sum up of what we learn working together with our customers to give you a bit of an insight on how to brew, let's say, a lager or how to brew an IPA. So,
Andrea,
yes.
Before we start, I think there's a very big main question that I can ask you. I already seen it in the chat also. The question is, does are homebrewers able to brew to produce low alcohol beers at home? That's a very big question.
I think will be very difficult because you have to be very, very clean and you have to pasteurize. And usually you don't have the option to pasteurize your beer at home. If you can find a way to pasteurize, maybe using very hot water, yes, but it will be, I think, a challenge. It's not impossible, but for sure it's challenging. Okay, going on. No problem. Going on with the recipes. So here we have an example of a recipe of a lager beer. So you can expect to use around 70 to 90% Pilsner malt. You can also, if you want a bit more body in your lager, you can also increment or less fermentable sugar, a 10-30% dextric malt or Munich malt to give a different type of mouthfeel. Imagine that you start at 5 Plato, so of course you have also to catch up a bit on the body of the beer. Optionally, of course, if you're not in Germany, you can also add some wheat flakes for giving you a better head stability, so for having a thicker foam. Other suggestion for me is to mesh pretty high and thick, so 75 degree and as I said, 2.5 water grist ratio. That will help you. Remember to pre-acidify your wort at 4.8 to 5, and also careful with bitterness. I'm saying that because actually I'm talking by experience. If you try to give the same IBU to a beer, to your regular beer with alcohol, to your non-alcoholic beer, generally you can usually throw the beer out of balance with having a very bitter beer. So my suggestion is start with some trial, and better to start a bit low on IBU, and then if you're not happy, increase them later on. Regarding fermentation, it's in 50 gram per hecto. It's good pitching rate, and again, 2-3 days fermentation. We speak about up to 4 days fermentation, but generally all the customer try to usually ferment between 2 and 3 days. The idea here is still, as soon as your beer is clean of the worty aldehydes and your main fermentation that happen usually in day 1, it's done. Crush cool it. As soon as you're happy with the flavor of the beer and the smell, crush cool it down at 2 degrees, because the product is still not stable. There are a lot of sugar in there. There is a lot of protein, so there is a pretty high chance that if you have any other yeast, maybe your normal yeast strain that is around your brewery, can enter the fermenter and actually give you a higher ABV and over attenuation. And this is what you don't want. So as soon as you're happy with the flavor, in 2-3 days, generally you can crush cool your beer. You can actually give a bit of extra maturation, and yeah, this it's a twist from my side. As I said, I'm Italian, so a bit of national pride. In Italy we make a beer style called Italian Pils, in which we dry up lightly with some German aroma hop the beer at the end. I think this can work also very well in low alcohol beer to give a bit more complexity. And of course, then you can filter your beer, and mandatory is, like for all low alcohol production, pasteurizing the beer. We suggest 60 to 120 PU, depending, of course, on your brewery and the process. But also here, what I suggest is, if you have a pasteurizer, you can make some bottle at different PU and then check when your micro is clear. Once your micro is clear, then this is your pasteurization unit that you should apply to your beer and your brewery.
Andrea, a little question for you.
Sure.
Somebody asked, you talk about dry hopping a lot. Is that something you think is necessary for NABLAB beers?
I would say that's a very good question. Thank you for this. I would say no, it's not necessary, but I think it kind of helps because the yeast is very, very clean. So if you make a beer just with this yeast, it will be very, very neutral. If this is what you want, maybe you want to make a very clean lager, then great, I think go for it, just for the yeast. But if you want to maybe make an IPA or give it a bit of a twist to your lager, a bit more of aroma, then I will suggest you to dry up the beer, because in that case you can add a bit more complexity. But I mean, I think Sam, to answer you, the best way is to a bit try it. You know what I mean? Try one with a bit, maybe you can split the batch in two. Try one without and one with a bit of dry hopping, and then you can compare which one you prefer. That, in my opinion, is the best way. It's still, as I said, it's still a very new market, a hot topic. So I think it's also part of the fun, to experiment a bit and see how you can actually achieve the flavor you like in your product.
Okay, cool. Thank you, Andrea. And now, before we proceed to the recipes again, somebody also asked, the water, the chemical. Should you adjust it in any way, or should it do anything, or is that not necessary?
Well, it depends. I think you can use the water that you're using for your main beer style. So very soft water, for example, if you're making a lager, or maybe you can Burtonize a bit the water if you are used to it. If you are making an IPA, of course, it depends. I think a lot also on which geographical position you are in and what is the hardness, and the concentration of salt in your water. But generally, I would say you can do the same you do for your standard brew in low alcohol beer. Okay, so I will proceed a bit with the recipe for the IPA. Here you can see two different recipes. I want to give a bit of a different approach, more the old school, if you want IPA, so more West Coast, or the new trend of the New England IPA. Basically, as you can see here, you can increase a bit the Plato, particularly if you increase the quantity of dextrin malt or, let's say, or flakes that you are using. On the, let's say, on the mesh side and the grist, I would suggest, of course, to use flake, oat, or wheat for New England IPA to give you the haziness, of course. While on the West Coast side, you can use it maybe for foam stability, but otherwise it's not needed. And also, again, temperature of meshing 75 degree or more and very thick mesh. Pre-acidify, again, I put kind of IBU brackets that are pretty small, and be very careful about large kettle addition, because actually otherwise I would say it's better to put a bit less in the kettle addition and maybe use more dry hopping or bittering hops, because otherwise you risk to unbalance a bit your beer. And of course, if you're making New England IPA, you're probably going to do Whirlpool or Cat or a Whirlpool addition. And in that case, you have to be careful to be below the 75 degrees so you don't extract the alpha acids and you get a beer that is way too bitter. On top of this, you see the fermentation parameters are pretty much the same, 2 to 4 days. As I said, when it's the smell and the taste is good for you, crash cool it. The big difference is in my opinion, in dry hopping. If you're making a non-alcoholic beer, West Coast style, I will suggest you to dry hop cool. So when you are actually in maturation or after you crash cool. While if you want a New England IPA, big chunk of the aroma also come a bit from the biotransformation of the yeast. And in this case, then it can make sense also to dry hop in fermentation or directly when you pitch the yeast. That's another option because the fermentation is very short to maximize the biotransformation power of the yeast. But be careful in this case, as we showed before, of the hop creep effect, in which you can actually increase a bit your alcohol content. So once again, I think it's better to make a bit of a trial and check it and see what works best for your process. So we are almost at the end of the presentation, and I know it has been a tough topic, and thank you everybody to be so patient to listen to me. Just I want to leave you with some key points that I summarize in this, let's say, best practices or do and don'ts. We split it in three. There is a part, of course, on the outside that is, and the suggestion here are again, mesh high and thick. So high temperature, thick mesh, water grist ratio 2.5 liter to kilo. And also try to use different malts if you want to enhance the body of your beer, or adjuncts if you want to dextrin malt or adjuncts to enhance the body and actually change also a bit the flavor of your beer. On top of this also, you can add some other products like Tetrad, or even Tetra hops, or for example, the other flakes to have a better head retention. So foam is important. And be careful also of adjusting your pH. You can maintain a higher pH during lautering to avoid astringency, but then be careful to adapt the pH when you're before transferring the beer to the fermenter at 4.8 to 5. Try to target a Plato that is at the beginning around 5. Then, of course, if you use a lot of dextrin malt or adjuncts, you can go a bit higher. And you don't need actually to oxygenate your beer. So oxygenation is not needed because the dry yeast is already grown in aerobiosis, so it has enough oxygen to grow in your beer and ferment. On the cold side, though, we said be careful with the pitching rate. We suggest the lowest pitching rate is 50 gram per hecto. You can do less, but if you do this, you kind of expose yourself to a risk, the risk of underpitching. So not clean out maybe all the aldehydes of your wort, and also the risk of spoilage. So something else in the brewery can actually take the lead and ferment other sugars. And this, I think, should be avoided. I will not risk it, to be honest. You can expect an attenuation of around 12 to 18%. If you make a very, let's say, fermentable mash, 20. And of course, if you want to be safe, dry up cool, or if you dry up warm, just be careful of the hop creep effect and make some trial with it to see how much increase you get. On top of this, try to prevent cross-contamination, so be extra vigilant and clean if you produce a low-alcohol beer, because again, you can have a different type of bacteria, spoilers, but also pathogen potentially growing in your beer. Avoid propagation and repitching. Of course, this is go with the points above on the cleanliness, and be very cautious when you crash cool. One thing, sorry, maybe I didn't mention, don't crash cool at 0 degree because there is not alcohol in the beer, and so you'll get ice out of your fermenter. And on these guys, believe me, I'm talking by experience, yeah? So because it happened to me. So be careful and to go at around 2 degrees, I mean, for crash cooling. On top of this, there are also some precautions you have to take in food safety. As I said, thermal pasteurization is the only method that is 100% secure to make your low alcohol beer. You can also add different preservative from the most, like in amber, like benzoate, to also product like Nagardo or other ketosan or kefir that actually reduce and have some and have an effect on some pathogen and some spoilers. But the only way to be completely safe, in my opinion, is thermal pasteurization. Therefore, this is what I suggest as best practice. And also, you have to try to heat
Hi,
a
Andrea.
pH.
Can
Yeah.
I interrupt you?
Yeah.
We have a few people that are asking when does pasteurization need to be done in the process?
Yeah,
Well,
maybe it's okay. I'm sorry, Andrea. Maybe it's okay because lots of questions. To take people through the process when decide, because somebody asked like, when do you start pasteurization, at what percent of alcohol, for example, above 0.5%, is it still necessary? What temperature? How long should I have to pasteurize into the bottle or not? So could you take them through the process?
Yes, so you will make your beer as normal. So you will make your brew with lower Plato and with all the things, maybe adapting the mash as a recipe, as we said before. Then once you transfer in your fermenter at 20 degrees, you will have around, in my opinion, 2 to 3 days or up to 4 days of fermentation. As soon as you hit your final gravity, which generally, let's say for a 5 Plato, you should expect around 0.5% of alcohol, you crash cool it down and let it there, and you can let there the beer until you think the taste is okay for you, yeah, even 1 day if you want, or until the yeast is settled and you can take it out easily. And then after you go to bottling or canning or whatever, and then you pasteurize the bottles or the cans. So that would be the best way, in my opinion, to pasteurize, because if you pasteurize before, for example, your flash pasteurizer, and then you bottle, you can have contamination in your last mile, let's say, so in your bottle or in your cans. I think in that case might be useful to use some of this other preservative if you pasteurize before transferring to a BBT tank and then going into the bottle, and maybe you can use some other type of preservative to actually not having a problem in your finished beer. But generally, pasteurization has to be done in the bottle or the can.
And any idea how to do that? Like for a home brewer or small microbrewery, how could you do that?
So for a home brewer, it's very difficult to get. So pasteurization, you count in pasteurization unit. You can search on Google. There are a couple of equations on this. It's a bit complicated for me to tell you exactly time and temperature because it takes quite a bit of time. Generally, you will have to arrive, I think, around 60 or 70 degree to the core of the product to actually pasteurize it for a certain amount of time. But of course, depend on the thickness of the bottle, the temperature of if you're making with steam or whatever. So can be a bit tricky to predict. I think option for small brewer is for sure the best is to, if you don't have a pasteurizer, is to go to someone that has a pasteurizer. Maybe there is some guys that I don't know are making, you know, canned tomatoes or anything like olives, in the glass jar, and maybe you can pack your beer, go there on the day, put there in their pasteurizer, pasteurize the beer, and then bring it back. That would be, I think, the best option, the safest option. If you want to do it at home, I think you can do it in a hot water bath. But yeah, you have to be pretty careful also because you will have water at around, I don't know, 70, 80 degrees, even more. So yeah, you have to be a bit careful doing this for your own safety.
And not heating something up, but cooling it down. Could cooling help to sterilize the beer?
No, it's not sterilizing the beer. Cool it will maintain the beer. So you can do it if you want to really drink it very, very fresh and you finish it all, but I will not suggest it, to be honest. So it's not thermal pasteurization has an effect when it actually kills the bacteria, while cooling something down is more bacteriostatic. So you just block it there, but some of the bacteria, even at cooling temperature, can grow. So it's tricky. I will not suggest this.
Okay, so even the cold filter sterilization, for example, is not really an option.
If you filter it up to you, if you make a cold sterilization is actually filtration. So if you filter and you have a cutoff that is that you can filter out yeast and also bacteria, then it's fine, yeah. But still, then you are filling it in a bottle, which is not completely sterile. So it's way better, I agree. But then I will use some of this natural preservative to try to keep the beer a bit, longer in shelf life. That would be my suggestion in that case.
Okay. All right. I had another question. I don't think Mendel, did you want to ask something?
They're also talking about re-fermentation in the bottle, of course, because as everybody knows, re-fermentation in a bottle will give you 0.3, 0.4% ABV. So maybe that's also something interesting to talk about.
You cannot re-ferment in the bottle with this yeast. The whole idea is, to take out the alcohol. If you will put another yeast inside, for re-fermentation, that yeast will be maltose positive. So we'll actually ferment all the sugar you have in, and you will have hand grenades and not beer. So you have to be very careful. Do not re-ferment low alcohol beer. And also one point here, just to finish, is if you have a draft system, also be extra cautious in your draft system, because again, this is a last mile. So maybe you make your beer amazing, you pasteurize it, you have top notch on cleaning this, and it will be really a pity that then with your draft system, there is some spoiler in it, and then the beer go to your customer contaminated. So also that it's key important. And more or less then I can stop the presentation and you can see me and we can continue with other questions. And thank you very much for the attention and for being here.
Thank you. Well, I have another one here. Somebody asks, what about working with acidulated malts? Is that a good option, or is that?
Yes, you can. If you want to reduce the pH instead of using lactic acid or phosphoric acid, it's definitely a good option. You can work with that, yeah.
Okay. Then another thing, cryo hops. Could that help you with the hop creep? Have any idea?
Well, it's not something I try, to be honest. I think you have to try and see. I think, maybe give you less, but
because you use less hops then? for the same
Yeah,
flavor?
well, yeah, but let's say yes, no. You have to be. I think it's something you have to try. All this thing of hop creep and hopping techniques is really something you have to try yourself. I think in your process, and then get what is best for you. Yeah, we generally, if you dry hop cold and then you pasteurize the beer, you can also use normal hops. I mean, at that point, the enzyme will be of the hops will be denaturated once you are pasteurizing the beer with the temperature. So at that point, you will not see any hop creep effect. The only hop creep effect is if you want to dry hop warm, so like at 20
Right.
degrees in fermentation. So then you have to be careful. And my suggestion is always make a trial first, see how it goes, check well the alcohol, readapt the recipe, maybe using even only 30% of base malt and a lot of dextrin malts or flakes. So you actually minimize the quantity of sugar that you can give to the yeast. So you can kind of mitigate this hop creep effect.
Okay. Another thing I saw is you mentioned to aim for 5.5 Plato wort and not higher. Let's say with a 5.5 wort, how do you calculate the ABV of the beer?
Well, the attenuation, as I said, is you can expect 10 to maximum 18, 20%. So then you can calculate what will be your extract and what will be your ABV with this data.
Okay.
On top of this, I mean, I said 5.5. That is what we suggest. But in our experience at breweries going even up to 8. But then again, you have to play a lot with your mesh and with your raw materials.
Okay. Another question came in about cold meshing. Have you heard about the technique?
Nope. No, I
No.
never did it.
Okay.
So I really
No.
have no clue on this. Sorry, I have no
Okay.
experience on this part
This is
part of it.
how could it fit into the NABLAB story? But again, yeah.
It's not something we
right.
tried. Maybe next time. That's an interesting one. I'll take it as a point to explore.
Cool. Will there be any 11-gram packages coming soon for the homebrewers?
I think no. This application is more, I think, for industrial craft and industrial market because of the difficulties of pasteurizing.
And the danger, yeah.
Yeah.
Okay.
They're
Then,
also
yeah.
talking in the chat about the re-fermentation because someone asked if I understand well, low alcohol beer is not CO2 free. So yeah, it needs to be carbonized, of course, afterwards.
Yes and no. It depends on the apparatus you have. You can close also the valve and use the natural CO2, or you can carbonate afterwards. I mean, up to you. But of course, yeah, you have to get some CO2 in it because you cannot re-ferment it. Otherwise, you'll have flat
Exactly.
beer. So definitely a good call, yeah. Carbonate your beer. Sorry, I forgot about it in all the speech, but that was a good shout.
Okay. Let's check for some questions.
There was also a question about the final specific gravity of the beer.
Well, I would say it depends a lot on your. Again, the attenuation is around 10 to 20%, so it will depend on your starting Plato, yeah, and your mesh and your grain bill, etc., and how you mesh. So, it's very difficult for me to give you prediction, but I would say if you have 10 to 20%, you can calculate then easily you're at more or less what will be your final extract, yeah.
Could it be a lot of people also ask, when do you have to pasteurize? And I mean, when is the alcohol level high enough, the ABV high enough to say it's safe?
So the whole point is to produce with the less ABV possible. So the idea is 0.5 is the maximum you can reach. Otherwise, you will not have low alcohol beer. So my main point on this will be that actually as soon is not to think about when it's finished or etc. It's like you have to compare it a bit like if you're making dairy, like if you're making a yogurt. You ferment it for 48 hours and then you don't want your yogurt to go bad, so you cool it down. That is the same approach you should have with our yeast, I think. This product is not stable because there is still a lot of sugar and protein in it, and therefore you will require pasteurization. But as soon as the flavor of the beer is okay, You clean out the worty aldehydes. You don't have diacetyl. You don't have a flavor. Just cool it down. Going to pack it, mature it if you want cold, that is possible, but at the point it's cold. It's around 2 degrees, so nothing will move, hopefully. And then pack it and kind of pasteurize it, and then you will have a great, in my opinion, a great result. That's the best thing I can suggest. I don't know if I answered the question on the what alcohol level is safe, but this is a process I would encourage you to use.
Yeah, somebody else. Yeah, say it,
you can go,
Mendel.
Sam. We can go.
No, I just saw it was a good question actually. How many breweries that you can say of are using your yeast in Belgium actually, or which kind of breweries you can talk about?
I mean, the one I shared are the one that actually give us permission to share the fact that we are collaborating with them because we presented this beer at this event. So for that, for sure, I can say we have collaboration ongoing in a lot of countries in Europe, Belgium included, Spain, Netherlands, Iceland, Germany, Switzerland, France, and hopefully more to come, Italy. So I mean, we have quite a lot of interest in this strain, and also, to be honest, it's a strain that, in my opinion, is very interesting, and our customers are pretty happy with it. So I mean, guys, maybe I mean. For now we have a name in the face, so for sure you can reach out then if you need to any help to develop recipes with some customer. You also go hand in hand together to actually develop the recipe with them. So of course for industrial customer we can give or craft brewer we can give also this kind of support.
Yeah, and it's also nice to know that we'll be sharing a discount code after this webinar for all the people who attended. So of a 20% on the Pinnacle yeasts at Brouwland. So we'll be sending you a code as well. So everybody was inspired and that wants to try something or wants to make a perfectly clean and crisp NABLAB beer. Let's say that's a good opportunity. Yeah.
Absolutely.
All right.
Indeed.
I think, Mendel, let's check one more time for some questions, and then we're gonna maybe do one more, and then after that we're gonna close down. I think, Andrea. I think everybody is clear. Also, a question was, can you share the presentation with them, or is it something you don't do? We actually didn't discuss it.
Yeah, this I have to check. I
Maybe a
don't know if I can share.
commercial version.
Exactly, a commercial version, maybe we can share. Yeah. One thing I really suggest you to do, big chunk of this, it's actually condensed on our website, which is Pinnacle Brewing Ingredients. Maybe I can copy it in the chat, or maybe Sam, you can send it over, whatever you
Yeah.
prefer. And there is actually a PIS, so a product information sheet, and a technical data sheet. The technical data sheet is kind of 5 pages and it's very comprehensive. So I really suggest you to look at this material to start with. And of course, you can always reach out if there is any, doubt or question. Yeah.
I think you can copy it in the chat, Andrea. That would be nice for everybody.
I will copy. Give me one moment still, and I will copy in the chat the information, where the link to the website when you can find all the information. Will be in English.
Yeah, that's good. Also for everybody who's still here, if you have some other questions or need some help with recipes or some things like that, you can also contact us at Brouwland, and we will be more than happy to help you with your questions.
Yeah, sure. I would also make sure there's a recording of the webinar available after the event, so we'll notice you when it's available. And you can check it again or look it up. That's no problem.
So here we go, guys. I just put the link in the chat so you can see it there. This is the link to our website, and then you can actually download all the information for application for the application note and the technical data sheets from there.
Okay. Okay, guys, I think we can wrap it up today. Andrea, everybody's sending you lots of thanks, and it was very
thank you,
informative.
guys.
So
You did it very great. Yeah.
Really,
Yeah.
guys, really thank to you guys at Broadland for organizing it and inviting me. I mean, it has been a pleasure. And also, guys, thank you very much for all of you staying up late to, hear me talking. I mean, I hope it was informative and interesting and not too boring, let's say.
No,
No,
it
it
wasn't.
was very, very nice.
Okay, everybody, thanks for
Hey, guys.
attending. And we're
Thanks.
looking forward to share the recording with you afterwards. So you'll see a notification or an email. You'll see. The code is also be coming your way through email.
Yeah, and you can also contact us if you need something or
No
if you have
problem.
some questions.
Yes. All right, guys. Thank you
Bye.
very
Cheers,
much.
guys.
Cheers.
Bye-bye. Have a great one.